AI and LLM applied in compliance to the ELI-DL structure of the EP, European Parliament Open Data. And with us is Christie Damnet, Data and Process Analyst of the European Parliament, and Jacques Militello, ICT Application Specialist, also the European Parliament. So, please.
So, hello, I'm Christie. As said, I'm a data and process analyst working in the Parliament for the past 22 years.
Hi, I'm Jacques Militello. I work for the European Parliament for 18 years ago, and I'm an IT architect, and I'm a new technology enthusiast. That's why I'm here today with Christie.
So we don't know too much about if it's a European habit, but by us at about this time, we normally have very often a coffee. And these coffee times are for us very magical moments because there are those moments you speak with your colleagues by accident of some issues, and it comes up a solution or a project draft on the corner of the table that works eventually possibly much better than what you would have drafted on your own. So that was the case with that one. We had a coffee, we spoke of all these things, and suddenly we came up with an idea of a proof of concept. We were having, we were willing to discuss about a conference we had last year on the close-up, and we were discussing how to go further than what we presented last year about the compliance of the Acoma and TOZO structure and the reference data that are used commonly to make the document more interoperable. And we wanted, one of our colleagues challenged us, saying all the past document may not be having this structure. And we were thinking, oh yeah, we have our tech guru with us, Jacques, and he said, why not using AI? And AI can certainly help in there to help us to retrieve some reference data, to retrieve some data in our document and help us to introduce them back into the system. So to drive you through our proof of concept, we need first to introduce a little bit the high-level structure of open data in the Parliament. But yeah, we have to say also that what we did can be, however, adapted to quite any system or any kind of data because it's running locally and completely independently of internet. Like this? Yeah, okay, sorry. Okay, so about the document. The document we produce in the Parliament are produced, of course, in those PDF format, which is very convenient for human readable, but they are also produced and very often even draft directly in some XML Acoma and TOZO format, which is XML-based machine-readable format designed to represent legal document, but we also use it for the preparatory document. We had yesterday a presentation on the AKN for EU by the publication office, our colleague Alejo Hernandez, and the one we use in the Parliament is very much the same. The metadata are coming in the Acoma and TOZO document together, and we are representing them in this document in a standardized way using the reference data from usually authority tables, taxonomies, and so on. In the EP, we use both the EU authority tables, which are maintained by the publication office, and for a few more specific parliamentary concepts, we use then a set of taxonomies, European Parliament taxonomies, that we map back to the authority tables of the EU each time it is possible. Inside some metadata, we are also using the ELI, which is a European legislative identifier, notably to build the links to legislative or preparatory document in a standardized way. The ELI specifications are maintained and developed by the ELI task force. For that task force, we have the chairperson in this room with us, who is Susana Gomez. So I really encourage you to approach us if you want any further information on those in ELI and all the ontologies that come with, which are used for modeling all the metadata around the legislative document and so on. In the Parliament, we are specifically interested in the ELI-DL, which is an ontology serving to describe the draft legislation metadata and all the related documentation that comes with. So ELI-DL is somehow the backbone of the open data portal in the Parliament, and all those key aspects, be it the ontology, the fact of using the reference data, and the accomantoso combined together, that give a sort of standard framework to describe the European Parliament legislative document and all the related metadata. It makes them more interoperable to other systems that are using the same or interrelated standards. About our proof of concept, we choose a set of documents from the open data portal of the Parliament, which represent the last legislature of the what we call written question of our members and all their answers. They are rather short documents because they do like a half page in average. However, they are very numerous because we have here a set of around 40,000 documents that we used. And what to say, they come in any of the 24 official languages, but we used mainly the English version of the question and their answers. So that's where Jacques made his magic. So I will let him present the technical part of the solutions.
Thank you. Then the scope of this small proof of concept is all the questions from the year 2020 until 2024. At a glance, the proof of concept stands on two pillars. The first one, and this normal pillar. The first one is the document ingestion, and the second one is the retrieval augmented generation, the RAG. Alors, why this approach? Because, in fact, we want a reliable answer with our citation over our data, our own data. Now, as you know, pure LLM are very impressive, but without retrieval, they hallucinate and drift. With the RAG, we ground response in our documents, so the answers are verifiable, auditable, and specific to us, without sending data outside of our walls. Alors, the pillar one, the document ingestion, what we did. Our ingestion pipeline turned raw legal document file from the question into a search-ready acknowledgement-based. First thing, we pass the parsing and the normalization. From our question is done with our question's legal document format. After we do small smart checking, our documents are split into semantically coherent chunks, not arbitrary slices, so retrieve context is very meaningful for us. After we turn it into embeddings, for that we are using a local OLAMA, our small llama that you can see on the screen. We generate vector representation with the nomic embedded text model. We store the chunks plus we enrich with metadata into PostgreSQL thanks to the PG vector extension. And this gives us a robust open source and queryable vector store. Also, what we did, we use GraphDB repository, and we populate it with the Turtle dataset that you can download it from the European Parliament data portal. For the pillar 2, for the retrieval augmented generation, in fact, when a user asks a question, we follow this flow. We lightly normalize the question and attach it into useful filter, normal research. For the retrieval, we fetch the most relevant chunks for PostgreSQL through PG vector using the embeddings. We augment also through the graph database to follow a relationship, like reference, version, authorship, and some other metadata. And after, we pass the curated context to a local language model. We are using a GPT OSS 20. In fact, this model is the ChatGPT O3 mini class. Is quite the same. And this is to generate the grounded answer. Alors, the 120 is not working on my local. Just a small message for my hierarchy if they want to provide me another device. And the answer includes citation back to the source chunk, so the reader can verify and trust our output. Alors, what this enables? Trusted answer with a receipt. Every claim can point back to a page, a paragraph, a repo, a question, or session document, and so on. Local-only data handling. No document leave this machine. Ideal for the sensitive content, of course. Compensable architecture. Each page, Olama, embedding, Postgre, PG vector, GraphDB can be upgraded independently. It's based on and the solution is based on a microservice architecture. And it's very friendly for developer. Alors, the thing that is very important is all of this POC is running on my local device. This is our main things. And other thing, the quality track of data, not just the model size. Better checking and cleaner source improve answer more than adding parameters. This is very, very important for us.
So the few use cases that we were following are about some incompleteness of data. And our aim was then to improve the content and the quality of a data set by making some data enrichment and to help also to enhance the search functionalities. The whole was asking the AI to find missing metadata or that a set of file would not be complete, such information, and then use the AI to try to complete those missing information retrieved. And the second axis of the use cases would be about the help human decision making by enhancing the search and the analysis of the data across large data set. We were thinking that the AI can provide us insight to enhance the data quality. And then using the AI to make statement and let us know where we could improve the missing informations. So maybe that's where we can also have our little video, because we were thinking of a live demo, but it's not exactly possible.
Alors, in fact, here you can see, it's a pure script. There is no UI and something like that. It's just for the POC. And in fact, we have processed 3 main questions about around all the questions. The first one is just to classify a little bit our question. Secondly, is to search about all the questions about one person. All the person, the name, and so on are removed for the demo. And after, for the third question is, can you help me to improve the tagging of our legal document to see if there is some missing metadata or missing stuff on this XML.
So this has led us to a few first statement, I would say, because we just tried. the human resource would request a lot more processing time to reach that result. They can also process a smaller data set only. They need a lot of training and skills to go through it. They may get bored also with those repetitive tasks. However, they can add a lot about the critical thinking and the out-of-the-box ideas, where for the AI-based tool,
Yes. Less processing time, we have a larger data set. We limit the training needs. Also, we remove the hallucination from the LLM thanks to this approach. And also, we have the... And in the future also, we can do some evaluation about preparing a lightweight benchmark for the question expecting sources to track how we can improve step by step over the time.
and for the very last, we would like to go through a very few ethical considerations. With the AI Act, the European Union has adopted a human-centric approach towards AI, emphasizing that the design, the development, the deployment, and the use of the AI system must be respectful of the European values, the human rights, and the fundamentals principle. So the EU-AI Act is establishing the world's first comprehensive legal framework for AI, classifying all the systems into 4 levels based on their potential to cause harms like unacceptable, high, limited, or minimal. The AI practice deemed a clear threat to fundamental rights are banned in the EU. So this includes, for example, the social scoring of the citizen, the exploitative manipulation of vulnerable groups, and indiscriminate the facial scrapping to create databases and so on. The high-risk AI system must be designed for human oversight, and they must also include technical measures for record keeping and logging to ensure accountability and traceability of the outcomes. And this approach is specifically aimed at fostering human-AI collaboration, ensuring that the AI systems serve as extended support, example given for data processing or automating repetitive tasks, rather than replacing the human and the core human decision-making. The framework emphasizes the need for human critical thinking and AI literacy to effectively interpret and apply the AI-treated data, thereby fulfilling the mandate to build and deploy trustworthy AIs that preserve human dignity. Thank you very much.
Great, thank you very much. Perfect example of how coffee breaks can also be brainstorm breaks. Quick question, how do you ensure the quality of the data set on parliamentary questions that have no clear structure? I've seen them.
In fact, in our dataset are already verified, and we have a dedicated chain to do this kind of verification. Our dataset as our input are already classified, are already verified. We don't need to validate it and to improve it.
Okay, very good. Yeah, I've seen firsthand how much the Parliament has moved from paper, from trees, to digital. It's quite striking because there are a lot of empty casiers now, and everything's just online. So this is all part of that process.